Click the bell icon to get latest videos from Ekeeda.
Hello friends, I welcome you all to this video. With this video, we are going to conclude the chapter that it was transmission with circular waveguide. So this is the last video. So far in this chapter, we have gone through first of all the understanding of the conventional type of transmission line. For example, it was the coaxial transmission line, and from it we have a modification by removing the central conductor. We are obtaining a circular waveguide with a hollow cavity inside, which guides the microwave from one microwave component to that of another in a microwave system for practical setup, we can say. We have addressed several of the topics related to not having the ideal TEM mode of wave propagation, hence the alternatives in the terms of transverse electric or transverse magnetic mode. We have solved few of the problems also, and in the previous video we are now well acquainted to how to have excitation for the circular waveguide to have the initiation of certain type of the modes, either TE or TM. So with respect to the various combinations in the subscript N and P here we have. So let us address the standard characteristics for the circular waveguide. In the previous chapter, we have also reported the characteristic of standard but rectangular waveguide there. So I hope you are very clear to have the knowledge that whatever the circular waveguide it is there, as the name circular refers to the circular cross section. So circular cross section for the inside dimension we have been using throughout the analysis with the help of several of the equations and the formulae for the performance metric. We can see here the radius we have denoted rho is equal to A. For analysis purpose, we have been using the cylindrical coordinate system where rho is the parameter to be having the radial direction, measuring the radius of the cylinder here. So here we have used A. So the question was whether the internal dimension small a is having any relationship with the operating frequency denoted by F of the waveguide there. The answer is yes. So as we are working with the microwaves here, we know that for microwaves the frequency range is from 1 gigahertz to that of 300 gigahertz. So this is the very wide range. We can have any kind of variation to the broad values in this complete range here. So if we have change in terms of frequency, so what is the requirement corresponding to the internal dimensions of the circular waveguide for the standard results we can say here. So there it is the relation here. So for example, if we want the frequency to be with the X band range, so as we can designate several of the bands dividing this entire frequency range, we go for the specific X band where the frequency range is from 8 gigahertz to that of 12 gigahertz. So we say this frequency band to be the X band, and when we want to operate the circular waveguide in the X band frequency range by EIA, that is standing for, we know it is Electronic Industry Association. So as per the EIA, Electronic Industry Association, we have been provided the standard values there. So for the inside dimension we have been using the value 2.383. So in terms of centimeters, when you want to get it in terms of inches, it measures to the value 0.938 inches here. So this will be the standard requirement of the inside radius of the circular waveguide if you want to work with the X band frequencies for the circular waveguide. So next to that, we shall be having a simple tabulation while varying the dimensions and the operative frequencies and the standard numbers given to the circular waveguides on this entire frequency range. So we get the first column for the tabulation by EIA designation. So corresponding to a particular frequency and the dimension of the circular waveguide, the combination, the device, it is a passive device, is designated by a certain number. So for example, we have 992 number of circular waveguide. So when we talk about the inside diameter here, so inside diameter can simply be represented by capital D. So capital D is equal to twice A, we can say here in the small case. So in terms of centimeters, we have the value for this EIA designation circular waveguide 25.184 in terms of centimeters. While getting it converted to the measurement in inches, we have 9.915 of inches here. While working with these dimensions designated by this number, the cutoff frequency that we have obtained while the circular waveguide is air filled. So the cutoff frequency is represented by FC. In terms of gigahertz, we have the value 0.698 gigahertz here. Whereas the recommended frequency range to work with this circular device, circular waveguide device, for the dominant mode of propagation, that it is TEM1. So we have frequency range in the last column, and here it is 0.80 up to 1.10 gigahertz here. So this is the sample example we have talked about. Another example we can take 329 we go for while the EIA designation to a circular waveguide. So the corresponding dimensions into the centimeter are 8.362 in terms of centimeter, whereas in inches we have 3.292 inches. The cutoff frequency we have corresponding to this device is 2.102 gigahertz, whereas the frequency range for the dominant mode is recommended to the values 2.42 up to 3.31 here in gigahertz again. Next to that, we can go for 80 value given by EIA. So it has a 2.024 in terms of centimeters, and in inches we have 0.797. So we have the cutoff frequency value 8.685 gigahertz, and the frequency range is 9.97 gigahertz up to 13.70 gigahertz here. At last, we can take the example with the EIA designation number 14. So we have the dimension 358, that it is 0.358 in centimeter, and in inches it is 0.141 inches, whereas the cutoff frequency value is 49.103 here in gigahertz, and the complete range is 56.60 to 77.50 gigahertz for the dominant mode of operation here. Now, one relationship you can observe to see all these four entries as we go for reducing the inside diameter here. So initially it was 25 centimeters approximately. We have reduced it to the 8 centimeter, 2 centimeter and 0.358 centimeter. So on the reduction of the dimension, you can see the cutoff frequency earlier it was 0.69 gigahertz. It increased to 2.102 gigahertz, then to 8.685 gigahertz, and finally to 49.103 gigahertz. So while reducing the dimension, that means While going for the miniaturization of the device, we work with the higher order frequency for the cutoff case, or in general the frequency range, it is the same behavior we know. So I hope the standard characteristics we have addressed is very clear to you people, and while working in the practical setup for demonstration of various experiments corresponding to microwave engineering, this information will definitely be helpful. This one, as well as the types with which we can either excite several types of modes inside the circular waveguide, or we can make the measurements corresponding to the strength of electric and the magnetic field vectors having the specific field patterns inside the rectangular and that of the circular waveguide currently in this particular chapter. So we have concluded this chapter, and by the next lecture we shall be starting with the new chapter corresponding to again the transmission of microwaves, but with the help of strip lines and micro strip lines. The comparative introduction we shall be addressing in the very first topic there. So I hope you really enjoy learning for the subject of microwave engineering. For more information like this and the knowledge if you want to gain, you can subscribe to Ekeeda channel. Thank you.